All right, so in assignment number 1, we simplified expressions that involved exponents. And so in this video, we're going to simplify expressions that involve radicals. So let's go ahead and get started. So with a simple radical expression that looks like this, we have several parts that we need to know the names of. So the little number above the radical sign is called the index. And then of course we have the radical sign. The number that's inside the radical side is called the radicand. And then when it's equal to a certain number, that is, at least in this case, called the principal root. It's the principal root because the fourth root of 81 could also be -3. But if they wanted the -3 to be there, they would have written it as the negative square root of 81. And if they wanted it to be plus or minus 3, then they would have written it as plus or minus the square root of 81. So that means that whenever we have a radical sign there, we want the principal root. So in this case, it's just going to be 3. So let's see if we can figure out what these problems would be. Try to figure out what these 4 problems are going to be on your own. Pause the video and then restart the video after you have tried them. So let's start with number 1, the cube root of -27. Well, that means we're looking for 3 things that when we multiply them together, we get a -27, and that would be -3 times -3 times -3. -3 times -3 is +9, but 9 times -3 is -27. So the cube root of -27 is simply -3. There are no i's here. It's simply -3. The cube root of +27 is +3. Then if I take the 5th root, some of these things are just going to be, we're going to have to figure those out. You can do this on your calculator. Under the math menu, there's a radical sign with an n up here. You can find any number of roots that you want to. But the 5th root of 32 is 2, and the 5th root of 243 is 3. And so the 5th root of 32 over 243 is simply 2/3. Then if we're going to solve this equation, we're going to take the square root of both sides. And so the square root of x squared is just x. The square root of 25 is plus or minus 5. Now we need the plus or minus here because there was no radical sign at the beginning in the original problem. We put the radical sign in there, and because we put the radical sign in there, we have to include all possibilities, which would include a +5 and a -5. So those are some examples to get us started, but let's take a look at a special case. If I take this expression here, 3 squared is 9, and then if I take the square root of 9, I get 3. And so we have said before that the square root and the square undo each other, so it just gives us 3. But does that work all the time? Is the square root of n squared always n? Let's take a look at a case that looks like this. If I take -3 and I square it, I get +9. But then the square root of +9 is +3, not -3. And so it doesn't always work. It would work if we include the absolute value around here. And so, in other words, if I had -3, it was my n, and then I took -3 and squared it, I got 9. Then I would take the square root of that. That would give me +3. And so this n will always end up being positive in that case. Doesn't always work that way because just like in the first example that we had, example number 1, we were taking the cube root of -27 and we got -3. So when do we have to make sure it becomes the positive? Well, it has to become a positive when we have something like this, where we have an even number on the outside, the index, and the even exponent, and that simplifies to something that is to an odd power. So for example, the example that we just had was if I took -3 squared and I took the square root of that, I have an even number here and an even number here, and it simplifies to a -3 to the first power. Because those undo each other, that's an even, and it simplifies to something that is odd. I have to put absolute values around here because it's going to end up being a +3. And so we have to remember to put absolute value bars around anything where there's an even and an even that simplifies to something that is odd. Let's talk about this in these next few examples. Let's take a look at number 5. The square root of 16x to the 6th. Well, I'm going to start by taking the square root of 16. The square root of 16 is just 4. But then I want to take the square root of x to the 6th power. Well, that's the same thing as x to the 3rd power. You may remember that if I have an exponent here and an index on the outside, I divide those two. 6 over 2 is 3. But I'm not finished yet because this is an even index and an even exponent, and those two simplify to something that is odd, so I need the absolute values around this. So the final answer is going to be 4 times the absolute value of x to the 3rd. Let's take a look at another example. Here's number 6. The 4th root of n to the 4th is just n, and that's an even. It simplifies to something that is odd, so it's absolute value of n. And the 4th root of y to the 8th is y to the 2nd. Now I don't need the absolute values around the y to the 2nd because when I take y and I square it, it's going to automatically be positive. So my final answer is just the absolute value of n and then y to the 2nd. Let's take a look at some that are a little bit more complicated than this. You might remember that when we were taking the square roots of numbers, we were looking for pairs of things that would come out of the exponent or out of the radical sign. Now we're looking for them in groups of 3. So one thing that we could do is we could take 128 and we could start a factor tree. That's 64 times 2. 64 is the same thing as 8 times 8. That's 4 times 2. And this 8 is also 4 times 2. So I can break both 4's down to 2 and 2. And this would be 2 and 2. And so I have a group of 3 here. I can pull that 2 out and another 2 out. So this 2 times this 2 is 4 on the outside. Then I have this leftover 2 that's going to have to stay inside the radical sign. Then I have 7 x's. Well, if I'm going to pull them out in groups of 3, that's 2 groups of 3 and 1 x left over inside the radical sign. Then I have 3 y's, which is one group of the y's. And so when I simplify this radical, my final answer is going to look something like this. I don't have to worry about any absolute value signs because this is an odd index here. And so it's not even odd. And so it's just going to be 4x to the 3rd y times the cube root of 2x. Let's take a look at another example here. Now I'm taking the 4th root of stuff. I already have a 3 on the outside. Let's start with the number. I'm going to take 432 and see if I can simplify that. That's going to be, I know a 4 goes into it. 4 times, I think that would be 108. And then 4 is 2 times 2. 108, let's see, I don't know. Let's try 2 and 54 just because I don't know any other factors of 108 off the top of my head. 54 I know is 27 times 2. 27 is 9 times 3, and 9 is 3 times 3. So I'm going to pull things out in groups of 4 this time because my index is 4. And so it looks like I have, here's 1, 2, 3, 4 2's. So I'm going to have a 2 on the outside that's going to join the 3 that's already there. So 3 times the 2 is a 6 on the outside. But then I have a 3, and a 3 left over on the inside. 3 times 3 times 3 is just 27. So it's going to be the 4th root of 27 still left over inside the radical sign. And so let's move on here and let's take a look at n to the 4th. That's 4 n's. I want to pull them out in groups of 4. So that's 1 n on the outside. That's an even, odd situation, so I need the absolute values around that. Then I have an m to the 8th, and I'm pulling those out in groups of 4. That's going to be 2 groups. That's m squared. And so my final answer is going to be 6 times the absolute value of n, m squared, times the 4th root of 27. Let's see how this might apply to a real situation. says the weight of an orange, this is true by the way, the weight of an orange can be found using this equation. The weight is equal to the diameter cubed divided by 4, where the diameter in inches is in inches and the weight is in ounces. So what is the diameter of an orange that weighs 5.5 ounces? Well, that means that the weight is 5.5, so I'm going to plug that in for W, and that equals D to the third over 4. So I'm going to simply get the D to the third by itself by multiplying both sides by 4. And if I take 5.5 times 4, that's going to be 20 plus 2, so that's 22 equals D to the third. And so then I want to undo the D to the third, so I'm going to take the cube root of both sides. And so I have D equals the cube root of 22, which is really close to 2.8. Okay, so I didn't simplify that, I just rounded to the nearest tenth. And so my diameter of my orange would be 2.8 inches. So this is what our homework assignment is about. We're going to be simplifying radicals, we have several problems to do like that. Good luck on your homework assignment, and we will talk about questions you have over that tomorrow in class.